Hi guys, this is a quick hint for problem number 47. Here we have like an origin where you have a plus 2 nanocoulomb charges, and then you have a second charge at a distance of 1 centimeter from the origin, and you can take this to be d for simplicity during our quadratic equation setup. And you have a second charge, and you can call it q2. This is a negative 4 nanocoulomb charge. Now, in order to find out where you want to bring a third charge, like a proton, Q3, you will have to assume that it's at a distance x from origin, right? That's where that would be easy, because only then you can just assume that the coordinate for Q3 is x, and then you find out two forces, and then you choose the right number for x, which makes sense from your assessment. In order to do that, you will have to quickly assume or quickly assess basically the three different zones you have. You have a zone 1 where you have basically everywhere to the left of Q1, right? So what happens places to the left of Q1? Let me draw it again. So if you have Q1, you have Q2, and you have Q3 here, right? So what happens here is you have a force which is directed away from Q1, and then you have another force which is towards Q2, because you are bringing a positive charge here. This is a positive charge, this is a negative charge, right? So is it possible for these two forces to neutralize? It's absolutely possible, because you have 2 nanocoulombs charge, you have 4 nanocoulombs charge. Because this is a larger charge, you want to keep your third charge as much away from um, Q2. So you want to bring it close or beyond Q1, so that no matter what this distance is always more. Okay, so it's absolutely possible that these two forces are equal in magnitude and opposite in direction, so that they cancel each other. Now, what happens if you come to zone 2? This is your zone 2. Zone 2 can have a place where you are real close to Q1, and then you have one force that is repelling, right? This is positive. If you bring another positive charge, that will be repulsion. But then you have attraction between these two guys, because you have a positive charge and this is a negative charge, right? So it will not work. It can never neutralize. These two forces can never neutralize because they are in the same direction. And in zone 3, let's call it zone 3. In zone 3, what you have is, if you have a positive charge somewhere here, they can never neutralize, because now you are close to Q2. So you are close to Q2, and Q2 has more charge, so this attractive force is way more than the repulsive force between Q1 and Q3. So this is not possible. This is not possible, or these are not your answers, let's say. It's only possible to have your final answer with a negative sign. So it has to be to the left of your origin. Okay, so once you find out a value of x, and you don't have to actually know anything about the exact value of or the sign of x, just take it to be as if it's somewhere in between q1 and q2, and then if x becomes a negative number, then it will automatically be on the other side. So your distances should be d between q1 and q2, x between q1 and q3. And remember, we are not saying what sign x has, and then the distance between these two guys, q3 and q2, will be d minus x. Okay, So proceed with that. Find out the two forces. You know how to find out forces using Coulomb's law. It will be K Q1 Q3 over first x square and then K Q1, excuse me, this should be a modulus sign, Q1, sorry, Q2 Q3 d minus x squared, and then you solve for x. This is 1 on 3, this is 2 on 3, and you then equate these two forces because they're equal in magnitude. Okay, and you are not talking about directions at this point because you have already taken modulus signs. So all you need to do is to find out two values for x in these two equations when you equate these two guys, and then choose the negative number because you have already seen it has to be to the left of origin. Okay, so I'll stop here. I hope this helps you to solve the problem, and I'll be back with more hints if needed. Bye.